Hello students, how are you? I hope you are fine. Today I have come up with around three questions from mechanics. Uh, these questions have been picked from the second shift or the afternoon shift of 24 January 2023 JEE mains exam. So let us discuss one by one. First question you can see. Uh, a body of mass 200 gram is tied to a spring of spring constant 12.5 Newton per meter while the other end of the spring is fixed at point O. If the body moves about O in a circular path on a smooth horizontal surface with constant angular speed 5 radians per second, then the ratio of extension in the spring to its natural length is. Right. This question is quite simple, student. Let us say that the original length of the spring is L. This is the original length of the spring. Now it is rotated. It is rotated. So while it starts rotating, naturally its length will be more, it will get extended. Let us say the extension is x. Okay, so this end is fixed, which becomes the center of the circle, and this is rotating like this. Okay, so you can see the radius is L plus x, and it is rotating with an angular speed omega. So for any block to rotate, there has to be a centripetal force, and here this centripetal force is nothing but the restoring force in the spring because of extension. So applying the law of circular dynamics, I can write the required centripetal force will be provided by the restoring force of the spring. The centripetal force required for the block to go around this circle. Now this is k into x, as you know, and this will be m omega square into radius. Radius is this, m omega square r. R is the radius. So therefore, we require what is to be calculated extension by natural length. So x by L is required. So I will divide both sides by L. So x by L is equal to m omega square into 1 plus x by L. Substituting the values, we get k is 12.5. I can write it as 25 by 2. X by L, I'll be taking it as say Z, which is what is required. So into Z is equal to m. Mass of the spring is 200 gram. 200 gram is 1 by 5 kg. Omega is 5 radian per second. So 5 into 5 into 1 plus Z. X by L I have taken as Z. So let us cancel the things there. 1 5 gets cancelled here and 1 5 gets cancelled here. Okay. So therefore we have 5 z is equal to 2 plus 2z. Therefore 3z is equal to 2. Therefore z is equal to 2 by 3. So correct option is the third option. I hope that is clear. Let us move to the next question, please. The velocity time graph of a body moving in a straight line is shown in the figure. The ratio of displacement to distance traveled by the body. Now they have given a graph, you can see they have shown a graph, okay, of velocity versus time curve. Now here you have to understand the nature of the movement. Okay, say this. Suppose I have to understand the nature of the movement. You see, initially let us say the body starts from O. Here the velocity is positive, so the displacement will be in the positive direction. Displacement is in the positive direction, you take the positive direction like this. Then here what is there? The displacement is in the negative direction because velocity is negative. Sorry. Velocity is in the negative direction. So displacement will be negative. Okay. Negative. Then here again positive, negative. So negative displacement in this direction. Now let us calculate the displacements here. As the area below the velocity versus time term, 8 into 2 this is 16. Here 4 into 2, 8 numerically. Here this is 4 into 4 again 16. And this is 2 into 2 that is 2 into 4 sorry that is 8. So the distance covered will be equal to 16 plus 8 plus 16 plus 8. So 16 plus 8 plus 16 plus 8. Okay, so this will be 8 6 are 48 units. Then coming to displacement, displacement will be 16, it comes back, so minus 8, again it moves in the forward direction, so plus 16 and then minus 8. So altogether it is 16 units. So the required ratio will be displacement to distance. So displacement is 16 units, distance is 48 units, so 1:3 is the correct answer. 1:3 is the correct answer. Okay. Right. Then coming to question 3. The body of mass 1 kg begins to move under the action of a time dependent force. You can see a time dependent force is given. The power developed by the above force. Now, while coming across questions based on powers, either you have to think in terms of energy consumed or energy generated per unit time, or maybe mechanical work executed per unit time, or the other formula is instantaneous power developed is always equal to the dot product of force and velocity. So the power developed is the dot product of force and velocity. Force is already given, isn't it? Force is already given, but we need to calculate the velocity there. So how to calculate velocity? Since mass is given, force is given, we can find acceleration. From acceleration we can obtain the expression for velocity, isn't it? Right. So the dog is barking. So acceleration will be equal to force by mass, is it? So which is same as this, t into I cap plus 3t square j cap, because mass is anyway 1. So I'll write this as dv by dt is this, so dv is this, dv is this. Now integrate both sides. Now unless otherwise mentioned, we'll assume the initial parameters to be 0, that is initial velocity is 0 because it is given that it begins to move. Also time can be taken as, initial time can be taken as 0. Now coming to the end velocity is v, and right now the time is t. So therefore this will be integral dv is v, here integral this will be t square by 2 into I cap, and this will be 3 t cube by 3 into j cap, integrated between the limits 0 to, here it will be 0 to v and here it will be 0 to t. So when you substitute the limits, you have upper limit minus lower limit, and here also t square by 2 I cap plus t cube j cap. So velocity vector is t square by 2 I cap plus t cube j cap. You know how to calculate the dot product. Multiply the coefficients of I cap together, then j cap together, okay, and then add them. So here it will be t into t square by 2 is how much? T cube by 2. Whereas here 3t square into t cube. This will be, sorry, 3t to the power 5. This is the instantaneous power. Since we have to calculate the instantaneous power at t equal to 2 seconds, put t equal to 2 seconds. So at t equal to 2 seconds, instantaneous power will be 2 cube by 2, and here it will be this. So this is 4 and this will be 3 into 32. Okay, so 4 plus 96, which is equal to 100 watt. So correct answer is 100 watt. So that's all students for in this video. I hope you are liking my way of teaching. Please subscribe to my channel and also hit the like button. Thank you so much.